We're going to have a little bit of a refresher on the concept of rounding and how to go about rounding. There's certainly more than one way to round, and the method that I'm going to show you here is just one possible way. I'm going to do an example specifically with rounding decimals because that's what we'll be doing for the next little while. So we might get a question such as the one in front of us here. Round each to the nearest centimeter. Now, if we look closely at the lengths shown in centimeters, in this case, when they ask us to round each to the nearest centimeter, they're actually asking us to round to the nearest whole number, because in this case, the centimeters are the whole numbers. So really, we can focus our attention on how to round to the nearest whole number. Now, here are some of the rules for rounding. Again, there's more than one way to go about this, but if we're going to use strict rules for rounding, when you need to round a number, you need to look at the number to the right of it to make a decision. If that number is 5 or greater, then we're going to round up. If that number is 4 or less, we're going to round down. Rounding down does not mean moving the number down. It means to leave the number alone and replace everything to its right with zeros. So let's do an example of what this might actually look like. The number that we're going to work with is 4.637. We've been asked to round to the nearest whole number. So the whole number in this question is the 4. In order to make our decision, as mentioned before, we look at the number immediately to the right. In this case, that number is on the other side of the decimal and is a 6. 6 is larger than 5, so we round up. The decimal 6 means that the number 4.637 is closer to the whole number 5 than it is to the whole number 4. So we change the number to be a 5. And in fact, we get rid of the decimal altogether. Let's look at another example. In fact, we'll look at the same number, but we'll round to a different decimal place. In this case, we're going to round to the nearest tenth. The 6 is in the tenths place, so that's the number that we may change. If we look to the right of the tenths, there is a 3. 3 is smaller than 5, so we're going to round down. But as mentioned before, this doesn't mean lowering the 6 to a 5. It means that the tenths are closer to the 6, which they're already at, than they would be to moving up to a 7. We would never move the 6 down to a 5. So rounding down means leave the number alone and replace everything to the right with 0. Now, in this particular case, with decimal numbers, you can actually drop all the trailing zeros. That can only be done with decimal numbers. And in fact, we did it with our last example as well. But here it's a little bit more obvious. The number becomes 4.600, and when we drop the zeros, the number becomes 4.6. So now we've seen an example of rounding up and an example of rounding down. The best way to understand all of this is to practice with it. So let's do a little bit of practice. We were initially given these questions. Round each to the nearest centimeter, and we determined that that was to the nearest whole number. Try rounding each of these numbers to the nearest centimeter. Let's try the first one there together. So the number is 17.37. And we've been asked to round to the nearest centimeter or the nearest whole number. Well, the whole number is the 17. And we know that to determine whether or not to round up, we need to look at the number directly to the right, which in this case is the 3. The rules for rounding tell us that if the number is 5 or greater, then we round up. In this case, the number is a 3. Well, 3 is less than 5, and therefore we need to round down. And rounding down, as we've discussed before, does not mean lowering 17 to 16, but rather leaving it as is. So this number is going to become 17.00. And with any decimal, we know that we can actually just erase the zeros because they're no longer necessary, and the number becomes just 17. Let's look at this on a number line. If we were to look at a number line, we would put 17 at one end and 18 at the other. Halfway between the two, we would want to put 17.5. Here, we would have 17.75, and around here we would have 17.25. So where would 17.37 fall? Well, it would fall somewhere between the 17.25 and the 17.5, probably somewhere around here. So if we now look at this again, we can help ourselves to understand why the rule exists. 17.37 is much closer to 17 than it is to 18. And the marker point is this point 5. And that's why we have this rule about the number 5 or greater, or a number that is less than 5 when we make our decision. So once again, our answer for that first one should be 17. Is that what you got? At this point, pause the video and see if you can complete the remainder of this chart by rounding each of the numbers to the nearest centimeter, or in other words, the nearest whole number. When you click play, wait a few moments before I share the answers with you. How did you do? I bet you did fantastic. Let's try a couple of other questions next. Just like a centimeter was actually the whole number, in this case the millimeter is actually rounding to tenths. Let's do one together again. We'll start with the one at the beginning, 17.37, the same number as last time. This time though, we're rounding to the nearest tenth, and the number in the tenths place is the 3. To make our decision this time, we need to look at the number that is in the hundredth place, the number to the right, which is the 7. If we follow our rule just as before, we're looking at that number to the right, and if it's bigger than a 5, we're going to round up. So in this case, we need to round the 3 up to a 4, which makes our new number 17.40. And as we mentioned before, we can actually get rid of the 0 because zeros at the end of a decimal number don't really matter. Let's look at this one on a number line as well. If we draw our number line, at one end we're going to have 17.3. At the other end we'll have 17.4. Halfway in the middle should be 17.35. If we divide up the space on either side, we're going to have 1, 2, 3, 4 divisions here, 1, 3, 4 divisions here. And if we label those, we'll have 17.31, 0.32, 0.33, 0.34, 0.35 is done, 0.36, 0.37, 0.38, 0.39, and 17.4. And so again, if we have to place 17.37, look at that. It's right here. And this is obviously much closer to the 0.4 than it would be to the 0.3. And therefore our new answer after rounding would be 17.4. Now see if you can complete the chart by rounding each of the numbers to the nearest tenth. Once again, pause the video and press play when you're ready to see the answers. Excellent. Now that you've had some practice, continue to work with rounding and see if you can get quicker at it. Rounding is a fantastic way of estimating, in particular if we have to start doing some operations on those numbers, such as addition, subtraction, multiplication, or division. To round the numbers ahead of time or to round the final answer can give us a close approximate answer.